Welcome, ladies and gentlemen, to your MN25 notes, where we are going to talk about reasoning and logic. You'll see this note guide has a lot of terms on the front. I'm going to define these terms and give an example of each one to kind of get us started with our reasoning and logic mini unit. Conjecture is the first word. Let me just write my definition. A conjecture is an unproven statement that is based on observation. And a lot of times when I think conjecture, I think conclusion. That's kind of the way I remember it. But conjecture is an unproven statement that is based on observation. So, for instance, here's an example. All even numbers are divisible by 2. So you can divide 2 into each even number. That's an observation. Now, so that's an example of conjecture. Inductive reasoning is a process that includes looking for patterns in making conjectures. So for instance, we do this in math a lot. We try to find patterns and then come up with the next kind of answer in that pattern. So inductive reasoning is a process that includes looking for patterns and making conclusions, or, using the word above, conjectures. So here's an example. We have 1, we have 3, we have 5, we have 7, ... We can make the conjecture or conclusion that the next number is going to be 7, oof, how about 9? 9 would be helpful. So 1, 3, 5, 7, obviously we're going up by 2s. The next number in the sequence would be 9. So this would be using inductive reasoning, which is a pattern-based approach to reasoning. Deductive reasoning is different. Deductive reasoning is a process that uses facts, definitions, properties, and laws of logic to form a logical argument. And I just want to say this, that when I think of deductive reasoning, I think a lot of what lawyers have to do to prove guilty or innocent. So I'm just saying they have to use facts, prior cases, logical arguments, the laws to prove their case. So let me write a definition for deductive reasoning. It's a process that uses facts, definitions, properties, and laws of logic to form a logical argument. And my example, I'm just going to say, is lawyer, a lawyer. And of course, there's many jobs that involve deductive reasoning, including mathematicians, but scientists use deductive reasoning, and so on. So inductive, deductive reasoning. Essentially, inductive reasoning is using patterns to come up with conjectures, and deductive reasoning is where you're using your laws of logic, facts, definition, property to create a series of logical arguments to prove your case. Conditional statement. A conditional statement is a type of logical statement that has two parts, a hypothesis and a conclusion. So let me just write that definition down. It's a type of logical statement that has two parts, the hypothesis and the conclusion. Okay, so a conditional statement is a type of logical statement that has two parts, a hypothesis and a conclusion. Here's an example, and we're going to kind of keep it straightforward just so this is a nice reference example. If the measure of angle A equals 90 degrees, then angle A is a right angle. Okay, so it consists of two parts. It's a conditional statement. I always think of conditional statements as the if-then statement. The hypothesis is the if part. So hypothesis is the if part of the conditional statement. So if you look at this example that we created, the hypothesis for that is, and I'm going to underline it, the hypothesis for this statement up here is this part right here, because that's the if part. If your measure of angle A is equal to 90 degrees, so if the measure of angle A is equal to 90 degrees, that's our hypothesis, and you can probably figure out that the conclusion is the then part. So let me write the conclusion definition. The then part of a conditional statement. So again, if we look right here, this is the then part. Oops, I'm going to use a different color here, not red. So if your measure of angle A is equal to 90 degrees, which is your hypothesis, then you can conclude that angle A is a right angle. So down here in our example for conclusion, it's angle A is a right angle. Okay, so just a lot of terms here, right? Okay, so hypothesis and conclusion make up a conditional statement. Now the converse is the conditional statement after flipping, or let me just say this, it's the statement after flipping the if and then part of the conditional statement. That's a lot of words, but let me just kind of say it again. The statement, so it's a converse if the statement has been flipped, essentially. So the statement after flipping the if and then part of a conditional statement. So, using our above example, if we flipped the hypothesis and the conclusion around, so we literally flipped it, we would say instead, if angle A is a right angle, then the measure of angle A is equal to 90 degrees. Okay, so a converse is literally just a flip. So I'm going to write flip right here. It's the flip of the conditional statement, the if-then conditional statement. A counterexample, it's a specific case that shows a conjecture is false. So it's literally the proof that your logic is wrong. So it's a specific case that shows a conjecture or conclusion, right? A conjecture is false or wrong. So for instance, if I have an example of a conjecture that all prime numbers are odd, the counterexample would be, because if you think about prime numbers, 1 is a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, not 6, 7 is a prime number, and so on. They are all odd, except if you notice 2. So a counterexample to this conclusion or conjecture is that 2. So prime numbers are all odd except for 2. 2 is my counterexample, which means that that statement, that conclusion, is wrong. Okay, one last word here. Biconditional statement is the statement that contains an if and only if. So I'm going to write that down. A statement that contains if and only if. And really definitions in general are a biconditional statement. And really what it means is it's true both ways. So let me just kind of write an example here. So let's start with the conditional statement we've been using. So we had if the measure of angle A is equal to 90 degrees, then angle A is right, a right angle, and that's true. Now if you reverse it and do the converse, if it's a right angle, then the measure is 90 degrees. That's also true. That means that you can write it as a biconditional. So the measure of angle A is equal to 90 degrees if and only if. So this right here is a shortcut saying if and only if angle A is a right angle. So a biconditional is where you take a conditional and a converse and get rid of the if and then and put an IFF in the middle, if and only if. Now if you flip this note guide over, you'll see we're going to use a lot of these terms. So for instance, use inductive reasoning for the next two numbers to find the pattern. I want you to try that. And I really want you to try really this whole back using the front definitions. And then from there, we're going to check it and make sure that you're understanding it tomorrow. Thank you for tuning in.